Alrighty, today we're doing 12.6 binomial distribution. So let's take a look first before we really get into binomial distribution about combinations. So we should be able to remember that we had combinations and permutations. And we need to look at, does order matter for combinations? So we should remember that from class and our previous videos, that for combinations, that's kind of like forming a group or a committee, right? So if I pick 4 people in this certain group, I pick person A, B, C, and D, it doesn't matter which order I say their names. It just matters that they are in the group or the committee or whatever you're forming. So for combinations, the order does not matter. It does not matter, okay? So what is the formula used for combinations? That is, we should remember, is NCR. N standing for how many you have. For example, if I have 30 people in a class and I say I'm going to form a committee of 5 of you guys to be on the math team, because I know all of you guys would be so excited to be on the math team and learn more about math, because math is awesome, then we would say N factorial over R factorial times N minus R factorial. And this is our equation for a combination, where N is how many people. For that example, would be 30. Combinations, your R would be how many you're picking from. So I'm going to pick 5 people to be on the math team, and then I'd plug it into here. And then we can evaluate this 12C3 by plugging into that formula. All right, we should also remember combinations also relates to Pascal's triangle, and we'll go over that a little bit more in a few slides. So a binomial experiment has 3 important features. The situation involves repeated trials, so you keep repeating it. Each trial has 2 possible outcomes, a success and a failure, which are going to add up to 100% when you add up their percentages, or 1 if you're adding up their decimal number. The probability of success is constant throughout the trials. The trials are independent. Okay? So let's take a look here. All right, well, we can't actually do this in Hawaii, but if you go to the mainland, then you can get some scratch-off cards, and it says that as part of a promotion, a store is giving away scratch-off cards. Prizes are awarded on 40% of the game cards. Suppose you have 3 cards. Okay, you're given 3 cards. Find the probability that exactly 2 of the 3 cards will reveal a prize. Okay, so if we are looking at that, then we know the probability of success, P, probability of success. Somebody's knocking at my door right now, but I'm not going to get up and get it. Probability of success is equal to 40% or 0.4. And the probability of failure, Q, this is probability of failure, is 60% or 0.6. Okay, so we're going to take a look here at making a tree diagram. We're going to make a tree diagram here. So let's take a look. We're either going to say we're going to get a prize or no prize. So the probability of getting a prize is 40% or 0.4. So on our first try, we either get a prize or no prize. Okay, so that's our first scratch-off card. We're going to do it again. So our next scratch-off card, we either get a prize or no prize. And for our last one, we either get a prize or no prize. So we want to find the probability that exactly 2 of the 3 cards will reveal a prize. So exactly 2 of the 3 cards will reveal a prize, meaning it will be success. So if we look at all of these branches here, this line is saying you get a prize, you get a prize, you get another prize. 3 prizes. This one here, we get a prize, no prize. This one here would be a prize, no prize, a prize. So we're going to write P, N, P. This one here, we get a prize, no prize, no prize, P, N, N. This one is no prize, 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 N, P, P. This one here, N, P, N. This one, N, N, P. And this one here, N, 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 triple N. So if we want to know the probability of getting exactly 2 of the 3 cards revealing a prize, so 2 prizes, let's look here. So here's one of them, one. This one is giving us 2 prizes because there's 2 P's. And this one is giving us 2 prizes also because there's 2 P's. Okay, so we had 3 times that we got a prize, or exactly 2 prizes, sorry. We know that the probability of success, we said, is 0.4. And we want 2 of those to give us success, 2 of the cards to give us a prize. The probability of failure is 0.6, and one of the times we'll get no prize or failure. Okay? And then we're just going to multiply this out. We'll do 3 times 0.4 squared times 0.6 will give us 0.288, which is the same as rating 28.8%. And that is the probability of getting exactly 2 prizes out of the 3 scratch-off cards. So this will be a little bit different if we have a different probability for success and failure. We also want to look at how can we get this number here, this 3, without actually making this tree diagram every time. So there is a reason why we went over the combinations earlier, and that's because we can find this number using combination. So if I have 3 scratch-off cards, I'm going to use that for the combinations, and I want to have 2 of them to be successful, meaning 2 of them to give me a prize. So 3C2 is the other way to find this number here. And 3C2 is equal to 3, and then you multiply it out. Okay, so here's actually the formula that we're going to write down. The probability of success is P, right here is P. The probability of failure is Q, right here is Q, where P and Q, when you add them up as decimals, you'll get a 1, or if you add them up as percentages, you'll get 100%. Okay, N will be the number of trials, and X will be the number of successes. So let's actually go ahead and, so this is a formula we're going to be using. We're going to write down the first 6 rows of the Pascal's triangle. So we have 1, 1, 1. We remember to find the numbers in Pascal's triangle. We just add the 2 numbers diagonally above it. So we have 1, 1 plus 2 is a 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1. I'm just adding up the 2 above it. 4 plus 6 is 10, 6 plus 4 is 10, like that. Okay, so this is actually the same as writing 0C0 is 1, that first one. The next row is 1C0 and 1C1. That's this row right here. This row, the second number is always going to be your first number in your combination. So this is going to be 2C0, 2C1, and 2C2. This row here is 3C0, 3C1, 3C2, and 3C3. This row is 4C0, 4C1, 4C2, 4C3, and 4C4. And finally, we have 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. So if you notice here, we can actually find the combinations by just looking at the corresponding number in Pascal's triangle. For example, 5C1 is 5. or 5C2 is 10, and so on. So we can use that for our equation up here when we're finding the binomial probability. Okay, so moving on here, let's take a look at if we have calculator. Calculator contains 4 batteries. With normal use, each battery has a 90% chance of lasting for 1 year. What is the probability that all 4 batteries will last a year? This is a binomial experiment, therefore we're going to use the formula that we just learned, where n is going to be 4 because there are 4 batteries. X is going to also be 4 because we want all 4 batteries to last all year, so 4. P will be a 90% chance that it will last all year, so 0.9 for P. Your Q will be 0.1 because it has to add up to 1 or 100%. And then we're just going to fill that in. Okay, so we have 4C4. We have P is 0.9 to the 4th. Q is 0.1 to the 0 because 4 minus 4 is 0. We know that 4C4, if we actually take a look back a slide at our Pascal's triangle, 4C4, or if these numbers are the same, you're always going to get your combination to be a 1. So 4C4 is 1. Okay, so that's 1 times, we'll do 0.9 to the 4th, and then anything to the 0 is a 1. Okay, so then we're going to find 0.9 to the 4th is going to give us 0.6561, which is 65.61%. So that is the probability that all 4 batteries will last all year. Moving on, let's take a look at guessing on a multiple choice test, which is never a good idea. Make sure you always study. We're going to prove that right now. It says suppose you guess on 4 questions. We have 4 questions. Okay, so we have question 1, 2, 3, and 4. And it's a 5-choice multiple choice test. So our choices are A, B, C, D, and E. So the probability that we get this correct is, there's only one correct, so the probability of success is 1/5 or 0.2, right? Only 1 out of the 5 of these is correct, so 0.2 is our probability of success. Our probability of failure then is 4 out of 5 of them are not correct, or 0.8, or 80% of them are not correct. Okay? We have 4 questions that we have to answer. That means n is 4. So here's what we have. So we're first going to look at, okay, what is our probability of getting 4 correct? Well, 4 correct means x would be 4. So I'm going to do 4C4, 0.2, which is my probability of correct, to the 4th, that's a 4, and 0.8 to the 0. Putting this in my calculator, 4C4 is a 1, a 0.2 to the 4th, anything to the 0 is a 1. And putting this in our calculator, which is answering the question of if I am going to just guess on these multiple choice questions, what's the probability that I get all 4 out of 4 correct? It's not going to be looking too good. Here is your chance of getting 4 out of 4, all of them correct. 0.0016 or 0.16% chance of getting them correct. That is way less than 1%. Not a good chance at all. That's not good. You could do it for all of them, getting 3 correct. Also not good. That's about 2.5% chance of getting 3 out of the 4 correct. Not good. 2 correct is about 15% chance of getting 2 out of the 4 correct. Also not very good. Getting 1 correct, about 41% chance, and 0 correct, also 41% chance. So it's a lot more likely that you'll get 0 correct than all 4 of them correct. If you add all of these up, we should come out with a 1. And then you can go ahead and graph the probability if you have 0 correct. We just found what that was. That was about 41% or 0.40196. All right, here's my bar graph. Beautiful bar graph. Yep. 2 correct is about 15 or 0.15. Sorry, this is misleading now because this is wider. Whoops. 0.02563 correct is about right here, not looking good. And 4 correct is almost at 0. I'm just going to draw a little line there. There we go. That's 4 correct. And that is making a binomial distribution graph. That's it. It's a wrap for today. Thanks for listening. Bye-bye.